This is a BBC Micro power supply. It needs servicing because its capacitors have gone bang and released their magic blue smoke. But we have this advanced servicing kit from retroclinic.com, so we can fix it. And we're going to fix it right now. Mark fixes stuff. This video is kindly sponsored by PCBWay. You can get an instant quote by simply uploading your PCB files, or you can select from a variety of talented designers' PCBs, add them to your cart and have them delivered directly to your door. The instructions warn that this kit is only for Aztec and BSR variants of the BBC PSU. As we can see, I have the BSR version, so we're good to go. The kit contains this hefty bag of components and some very detailed instructions that we'll follow closely. Let's see what's in the bag. A few flashy red cable ties, capacitors including these genuine reefer smoothing caps, the other capacitors are high quality Panasonic brand. Let's make some space. The first thing the instructions say is to remove the metal surround. Here we go. Let's turn the supply over so we can see what we're working on. First we need to remove the two earth bonding nuts, star washers and screws. The first one's here. You can usually just use your finger on the nuts. It's best to keep the nuts and star washers with the bolts, although it looks like I've already dropped the washer. We'll find that in a moment. The second earth bonding bolt is at the other end of the PSU. Same process. Don't worry if you drop the washer, we'll retrieve it easily later. A quick shake of your unit and the bits fall out. With the second screw washer and nut found, we just need to look out for that first star washer. It was stuck to the earth cable. Result. With that disaster averted, it's time to expose our units. There are 3 screws holding the PSU board into the case. Here, here, and this one that some lunatic has filled with thread lock. These just unscrew but do have flat washers, so make sure we keep them all. Don't worry about fishing them out now, everything will end up on the bench anyway. Someone's having a laugh. Nurse, scalpel please. Ha! MFS 1, thread lock nil. Next we need to remove the electrical switch terminals. First, chop the cable tie holding the input side wiring. Pull off the spade connectors If I were to do this again, I'd disconnect these after taking the switch out of the case to give myself some more room to work in. The instructions actually say to do it after, but there was no crown diagram. I never claimed to be smart. Blimey, Charlie. Grunting and panting sound effects. Sound of sweat hitting the desk. Well, lesson learned. Let's take the switch out now. It simply needs the case grips flattening down whilst you squeeze it out. And here's the switch. Note that the metal terminals are at the bottom of the switch. Removing the auxiliary power connector is more of the same, but easier because the grip's on the outside of the case. It can be quite hard to take it out of the hole. Another cable tie, so let's get that out of the way. Bits of reefer everywhere. The board can be removed from the metal case now, so let's do that. And the obligatory retro repair dead bug inside. Ooh, vacuuming sound effect. With the board out, we need to get the capacitors out. We'll start with the two X2 suppression caps at locations C1 and C2. Next, we'll take out the startup cap at location C9. Then we'll take out this huge pair at C6 and C8. And then C16 to 21 on the low voltage smoothing side. C1 and 2 first, they're the common problem. I'm going to use my desoldering station because I'm lazy. If you want a decent manual sucker, get an SS02. I use mine daily. It has a silicone nozzle so it can get right into the molten solder without melting. Affiliate link below. No need to note the values of the caps you remove because the instructions are comprehensive. Some replacements are higher values for better performance anyway. Using the desolder station, the caps come out easily. I'll pop a link to that tool below as well. This cap is still intact, but showing stress fracture lines. C2 is certainly not intact, and has clearly gone to capacitor Valhalla. The component is falling to bits as I remove it, making it hard to get my grip. Okay, this one might have failed. Blimey, what a massive crack! Looking at the component location in the X2, you can see exactly where it's got overheated and squirted all over the face of the board. Okay, let's pull C9 out next. We'll be moving faster now. I use my fingers from the rear to help locate the right part. Note that electrolytic capacitors usually have the negative leg marked on the component case. This board shows the location of the positive terminal. We'll come back to that later. C6 and C8 are next to be evicted. They were hot glued in the factory to stop vibrations causing the solder joints to fail. Moving on to the low voltage side of the board, the removal process is the same, so we'll shoot right past this and come back with the capacitors all removed. Let's go! Okay, all clear. The board is filthy though. A clean board is the most important factor in successful soldering. We're using 99.9% pure isopropyl alcohol to clean the vacated solder locations. This removes grease and other contaminants that can stop the solder taking to the joint. The top side of the board is equally dirty. Some of it is staining and won't come off, but cleaning the areas we'll be working on will make the job easier. Whilst I'm hard at work cleaning, it feels like a good time to let you know that you can help support future videos from Mark Fixes Stuff by joining up at patreon.com/MarkFixesStuff. You'll get early ad-free access to new videos, Patreon perks, exclusive content and other exciting benefits. Become an MFS hero and sign up today at patreon.com/MarkFixesStuff. After dislodging the initial grunge and grime, we'll give it another rinse down with some more IPA. This secondary sloshing seems to make a kind of capacitor casserole on the board. Okay, so I'll be the first to admit this isn't perfect, but it's good enough for what we're working with. Let's dry this off with a clean cotton swab. Try and get it into all the nooks and crannies, but the IPA will evaporate quickly anyway. The board is as clean as it's going to get. Let's grab a reefer and start to install the capacitors. These two look similar, but they are not the same. Be sure to install them in the correct places. The 10 nanofarad X2 goes into C1. Once I've placed my part in, I like to spread the legs out so the component stays put. C2 takes the 100 nanofarad reefer. These X2 caps are not polarised, so you can put them in either way around. With the suppression caps in place, let's solder them in. I'm going to use some extra liquid flux. It really makes the job easier. Flux helps the new solder flow onto the component legs and pads. Make sure you have good ventilation though. To solder the component in, we heat the solder pad on the board and the leg at the same time. This helps the solder to flow evenly. If one part is hotter than the other, then the solder will flow towards that first, making a poor joint. Snip off the extra legs with some sharp side cutters. Be sure not to cut into the joint itself or you could rip the pad from the board. If we look closely, we can see the flux burning off of the board and the solder flowing onto the freshly fluxed joint. As the heat radiates out through the solder pad, you can see the solder following the flow of the heat. Here's one from another angle. Remember, a good solder joint should be slightly convex, like a volcano, and that means that the solder has flowed into the hole. Again, removing the component legs. The legs are sometimes called leads. Time to install the startup cap at location C9. A 220 microfarad part rated for voltages up to 35 volts. Remember that the negative leg is marked on capacitors. That's standard. The positive leg on a cap is longer as well. The positive hole is printed on this board, so we'll put the longest leg through that. Again, we'll spread the legs wide open to keep it in place. Time to install C6 and C8. These are 100 microfarad parts, rated for up to 250 volts. Make sure these go in the right way round or they'll explode very, very quickly. Long leg in the positive hole. And same again. More flux because why make the job harder? Super speedy soldering as we pick up the pace now. And some swift snipping. So the suppression caps, the startup cap and the main smoothing caps are installed. Now we can move over to the low voltage side of the PSU. Locations C18 and C21 will be refitted with 220 microfarad 35 volt caps. The original caps were 100 microfarad parts, but this change will improve the smoothing on the -5 volts line. Long positive leg into the positive hole at C18 and bend the legs out. Same for C21. 220 microfarads, 35 volts and bend those legs. Let's pop the other caps in before we solder. C16, C19 and C20 are all 1000 microfarad, 25 volt rated. Pay attention to the polarity and triple check your work. It's really easy to make a mistake if you lose concentration. With C16, 19 and 20 in place, we can put the final cap into C17. This final part is a 2200 microfarad 16 volt part, and the process is exactly the same. Not sure if I've mentioned flux, link below. There's many types of flux. I personally like the liquid no clean variety for this kind of work. No clean means that the residues left behind won't corrode the board over time, so check your fluxes. The solder I'm using here is leaded. Modern devices use unleaded solder, but this PSU would have used leaded back in the 80s. Using unleaded solder on top of leaded solder leads to fragile solder joints. And the final solder joint is made. Phew. Just a little snipping to do and we can reassemble the PSU. Always check that you've snipped every lead and also that you've not left any lying around on the board or in the case. Some fluxes are sticky. Note that some components look like they're coated in brown toffee. This is normal and meant to suppress vibrations. Because they vibrate, you should check the solder joints on the input choke and the two transformers in case they've cracked due to mechanical stress. Look close up and see if there's any concentric rings or hairline fractures. If you wiggle the component, you can often see the legs moving within the solder joints if they are dry or broken. An inspection of the solder joints on all three show them to be fine, but you could reflow yours if you're not sure. Right, let's get this back into the case. It's pretty much the reverse of the earlier process. Push the external power connector back into place. The top and bottom of the connector should clip in with a firm snap. Pushing up and down on the connector will help to draw it through. Make sure the earth bonding cable is in the right position for reconnection. And let's fix the board to the metal case, not forgetting those washers. Just to annoy people, I'm putting the thread lock screw back in the wrong place. Last one of the three. Time to replace the switch. Make sure you have the 4 contacts towards the bottom of the part. This time I'll feed the cables out to the switch before I push it into the case. We'll do the wires connected to the board first. Make sure they're firmly replaced and pay attention to the locations of the live and neutral wires. Once those are fitted, take the blue and brown wires from the mains cable that enters the metal case. Feed those through the switch hole and install that onto the switch. Note that they must go on the same side as the other live and neutral wires. With the wires firmly fitted, we just pop the switch in. Grab a screw with a star washer and nut and we can fix the earth bonding cables back to the case. Pair up the lugs and thread the screw through the hole. The star washer needs to be on the case side. Next, pop on the 2 earthing lugs. Then, holding the nut, start screwing with your fingers. Once it's together, you can use the screwdriver until it's finger tight. Finally, finish off with some grips or a spanner. It's the same process up the rear end, except there's only one lug to deal with. Pop it through the hole. Slip on that star washer. Slide on the lug. And fumble with your nut in the dark until you can start screwing. Again, we'll use our fingers for starters. Then add in the screwdriver. Then we'll get the grips in to finish off. Using a cable tie, make sure that the wires are tidy. I've not tied this one to the switch itself because I can't get the wiring routed that way. But after snipping, it's nice and tidy. Same process on the low voltage side to keep the wires out of the way of the heatsink. Cut down the excess cable tie for a neat job. Finally, ensure that the power feed cables for the BBC are all untangled and intact, and we are done. So there we have it. A fully serviced BBC power supply and not an innuendo in sight. Big thank you to retroclinic.com for making these high quality kits. And a big thank you to my amazing Patreon supporters. They're on the screen now and make these videos possible. You can join them at patreon.com/MarkFixesStuff. Thanks so much for watching this video. Here's some others you can watch. Bye.